Andy, you're the founding CTO of Kodiak. How did you first approach developing an autonomous driving stack?
Yeah, thanks, Grayson. Thanks for having me here today. And I'm really happy to talk about Kodiak today. As an avid listener of the Road to Autonomy, it's awesome to be on the show. So we started off looking into what can we do to build a super versatile system that, of course, safety first was something that we looked into from the beginning. It has to be safe or it's not worth doing. And so that was our first pillar of how we approached it. But then we also realized very quickly that there's lots of learnings out there on how to do robotics, how to do autonomous driving. So we hired a great team around this, not just experts in the field of all the components of the autonomous vehicle, but who've actually had these learnings and had actually seen, well, these approaches work well, but these other ones, even more importantly, don't work very well. And then you need to go and build a framework for people to experiment in a safe way, that they can actually go and look into what works best, how should we approach this problem. So that's how we have built up the company from the beginning, how I have built up the engineering team here. And yeah, well, I think we'll talk about how that led to a very fruitful solution.
Versatility is fascinating because it's paying massive dividends today and it'll continue to pay dividends going into the future. Why did you build versatility into the engineering program on day one?
Yeah, I would say on day one, we were really focused on over the road, so meaning on highway trucking. And that autonomous trucking quickly showed us, well, there's lots of things out there that you need to handle, from regular ACCing, so basically following other vehicles, to merges. That's what people usually think about when you think of highway driving. But then there's lots of things like potholes or debris, or there's lots of pedestrians on a highway as well. And we quickly learned that these are all things we have to handle, and that we need a lot of structure testing, a lot of other scenes, and to put into our AI to get to a very robust and safe product. And that's how we started to look into the versatility of that, collecting lots of various different data and making sure that we build a very comprehensive driver. So that's how we got into this. And by now we can actually drive in various different industries, from over-the-road trucking to the defense space to an industrial space.
There's flexibility. There's flexibility in your hardware because you have different versions of the SensorPods. You have defense pods and you have your traditional SensorPods. But then I'm assuming there has to be software flexibility. Is there different stacks that for doing different applications, or how did you build flexibility into the Kodiak software stack?
Yeah, I think that's actually very special about the Kodiak software stack. So our software can drive from highways, high speed on highways, all the way to roads, high-speed roads with oncoming traffic, surface streets, dirt roads, all the way through a muddy field, right? And it's all running on the same software. So how do we do that? It really comes down to the AI behind it. And as I talked about in the very beginning, it's the room for experimentation that you need to create, and safe experimentation. So we have what we call a modular neural architecture, and that allows us to have several neural pathways that are in parallel. And if you to make this more clear, it's really neural networks that you can add to this architecture that actually go in parallel, which allows you to always use the latest and greatest of the state of the art of research. We test that, we make sure it's safe, we make sure it can be verified on the road, but especially in simulation. We run lots of simulations every day. We take these vehicles to the track. We see how they perform in various different ODDs. And as we expand our ODD, the operational design domain, and go from on-road trucking to defense to industrial use cases, we can just add additional neural pathways to it and make sure the system is safe. And so that framework of experimentation, that ability to add to the system, is incredibly powerful and helps us achieve that versatility with one and the same software.
I'm going to put a neural pathway in simple terms. Are you just downloading Encyclopedia Britannica? So if I sat there and read the whole Encyclopedia Britannica and became an expert on, say, military history or a different type of history, for your becoming an expert in that driving, is that what you're doing? Just giving the system more information to become an expert in that domain, whether it's off-road or whether it's defense?
I would say there's lots of data in it. So we drove more than 3 million miles at this point. So we have seen a lot of things out in the world. And we absolutely use this data for every part of our system. So it's a very data-driven system. However, there's also rules of the road, right? There is best practices in how you drive on highways, but also in defense. There is actually a lot of known doctrine on how you actually approach certain situations. And so you want to have a method to get that information in as well. That's maybe where the encyclopedia comes in. It's both data that you see out in the world, but also guidelines around it. Now, that is not to be confused when people say like, this is kind of a rules-based system. It's all handcrafted. That's not at all what we do, right? We use learning in every single component of our system, but it's important to have a verifiable AI system to actually be able to launch it. And as I'm sure you've seen, that's what we're doing. We're actually launching these systems driverless on the roads today.
Is that approach what's allowed Kodiak to scale safely across multiple domains?
Yes, absolutely. We do build up a safety case that consists of several different pillars. So first, you need to have a safety culture. That's very important. If you don't have the safety culture, it's hard to make decisions and come to conclusions because you can't monitor every single person every day. And so really having that culture is crucial. Then you want to design your system to be safe. And there's a lot that goes into this, from functional safety over kind of what is known as SOTIF, which really says, well, how is the behavior that you do safe? And we do a lot of risk analysis there. There's a lot of probabilities involved there in figuring out what is actually a safe thing to do. And then you go and say, well, now I've designed it, but I need to manufacture it in a safe way. I then need to operate it in a safe way. And I go and make sure that it's, from a cybersecurity point of view, that it's safe. And finally, you want to monitor your system, because you will always, as you drive more and more, you will encounter new situations that you might not have seen. You want to make sure that you stay safe, even in these situations and even as your environment changes.
I was listening to a really interesting podcast last week with Mark Andreessen and Ben Horowitz around AI. And Mr. Andreessen talked about hallucinations around Gen AI. And if you look at, especially one of your competitors in the field, is everything can go end to end without any, let's use the Eric Schmidt term, adult supervision, because going back to your Alphabet days, it seems that you need to have that oversight in order to successfully do this, because as Mr. Andreessen said, the system can hallucinate. Is that what you're doing? You're allowing the neural networks to work, but you're providing that supervision to make sure they stay within their guidelines within a safety framework?
Yes, that's absolutely correct. We do use generative AI in various different components, but being able to build a verifiable AI, right, that you can then build this safety case around is incredibly important. And our Gen AI is really around LLMs, but we also use VLMs. So basically fusing in visual data as well to make sure that we can recognize scenes that we can describe, but maybe have never seen. And since we have so much data out there, our own data, but also other data that we have access to, that actually gives us a huge foundation for all of our models and lets us build a really robust and scalable AI.
How do you test the AI for, if you look at the recently announced Atlas Energy deal, congratulations on that. That's running in the Permian Basin. There is heat, there is wind, there is dust. And if you look at your defense with Department of Defense, with the DIU Defense Innovation Unit, there's mud. There's all sorts of other elements there. And then if you're on road, as you've been very kind to put me in your truck, we saw people walking on the highway in Texas, saw somebody walking a dog, somebody riding a bicycle, and we've seen debris in the road. Your system was able to handle that. How do you train for all these different scenarios, since the environments are those three environments are completely different?
Yeah, it's one of the beauties that these parts are really additive and not distracting from each other. So we see that they basically cross-pollinate, right? Like we actually go and we run over the road, and that gives us lots of miles. It lets us test the hardware, see that we actually have the reliability over many hours of driving, many miles of driving. And then we take the same hardware, and we can talk about that as well. It's actually very modular and really testing the same things in the different use cases. But we take that same hardware and we run it in a defense setting, and we see lots of potholes, we see lots of shock and vibe, we see lots of heat in various different environments where there's bushes and lots of obstacles that you usually don't see in a highway environment. And so putting those two together is actually what usually people pay a lot of money for to see one or the other. People would go and say, hey, I need this structured testing and I have an entry structured testing campaign. Well, we can do this in the defense environment and actually use those learnings. And then people also go and say, I need to do accelerated life testing and get many, many miles on something. Well, we get that from the on-road trucking part. And so when you put the two together, actually this Atlas deployment in the Permian Basin, where we now haul lots of frac sand and where we have deployed driverless, we just announced that recently, that is actually a great application where those two get fused together. Because what you need to do when you go to various different well sites is they actually change. You need to go to various different locations. It's very sandy and dusty out there. So you might not actually exactly see where the road is every day. And it's something that really our stack has been built for from the beginning.
You look at the Permian Basin. You're running on dirt roads. You're not running on paved roads with markers. Are you relying on mapping technology? How are you doing that?
So from day one at Kodiak, we did not use HD maps. And maybe to explain to listeners who are not familiar with that, many companies go out and they create a very detailed picture of the world at some point. And that you could say that's a very high spatial resolution, but very low temporal resolution, because you do it once and then you usually don't update it for a long time because it's hard to update it. It's a lot of work to create these maps. And Kodiak takes a different approach. We actually use a very maybe low resolution in terms of spatial. We just say, hey, how do I get from A to B? Kind of more like you would imagine your Google Maps technology work and how to tell you what the route is. We know on a highway where the exits are. We know in these other networks like how you want to go from point A to B in a defense setting. And then we go and drive that. But we use our onboard perception to say, hey, where should we drive? How does the road actually look today? Did the highway change? Did someone come and move the lane markers? Where is the drivable surface in such a sand environment? Are there lots of piles of sand on the side of the road that we shouldn't drive into? Right? It doesn't matter that 2 weeks ago this was drivable. If today there's a big sandbank, you probably shouldn't drive through it.
If you had to rely on HD maps, would you be able to do the deployment with Atlas Energy?
We would not be able to do that. Okay,
so they're chalked it up to a competitive advantage.
Absolutely, yes. I think both the not relying on maps, still using maps if they're applicable, right? If we drive several times, we use maps as a prior. We pull them in and say, well, yesterday it looked this way. That's, of course, very useful. You don't want to reinvent the wheel every day, but you use those maps as a sensor. And a sensor can have missing data. It can have incorrect data. It has uncertainties. And so we take all of that information in and we look at, well, how much does it match what we see? And if it doesn't match and we're not quite certain about where exactly to drive, we have to slow down as a human would.
It's a cautious approach. Let's throw caution out the window here. Look at, if you're operating with the military and theater, caution goes out the window. You have a mission. How do you deploy the technology in theater?
Yeah, what we actually learned over time is that lots of military missions are not combat missions. You actually want to move vehicles, you want to reposition them, you want to get into an overwatch position where you might not want to be detected. And it's not actually a direct conflict in a lot of cases. And so when you do that, oftentimes you actually move on roads. Is it dirt roads? It can be 2-track roads. It can be actually through a field where you know it's drivable. You also don't want your vehicle to get stuck. Now, the properties of where you can drive, that matters a lot of what you're transporting and what your vehicle is. So if you have a big semi, which the military, of course, uses as well to do logistics in the field and in theater, then you might want to go on different roads and different paths than if you drive a pickup truck like we're using as well. We have an F-150 in our carpool, essentially. And it's very different also than if you use a tank, right? You just can run over different things. You take different routes. And so our system has actually been designed to handle all of those and take the properties of the vehicle into account. And we learned that it's really important to give the Department of Defense a way to plan those missions, to say what are the properties of the vehicle? What do you want to achieve? Does it have to be fast? Does it have to be slow? And even, do you want to remotely assist or maybe even remotely drive a certain vehicle? And that has been extremely useful in all the interactions we have and had with the Army.
The Army is a fascinating logistical enterprise. The men and women in harm's way, to thank them for their service. But if you look at it from a logistical standpoint, the Army moves plenty of goods over our nation's highways from base to base. As Kodiak expands the relationship with the Department of Defense, perhaps could you go from a base in, say, southern Texas to Oklahoma and start running logistical routes for the Army using your over-the-road technology as addition to your off-road technology?
Yes, absolutely. And that can scale to a worldwide environment as well. There's lots of semis being used in the Army, lots of goods to be transported. And I think some people even say wars are won not directly with weapons, but they're actually won with logistics. And I think that's where we can actually help and make sure that we stay at the forefront there.
You have to make sure that the front line has all the supplies that they need, because if you run out of water, you run out of ammo, you're in deep doo-doo. There's no other way to say that. See, that's the software side of the Kodiak stack. Then you've got, I'm a very big fan, I'm an unbiased fan because I think it's absolutely brilliant. You have SensorPods. And you have the defense pods for defense, and you have the traditional SensorPods, which are cool. And I've done a pull-up on them. I couldn't believe that actually held me. Where, how, and why was the SensorPod concept developed?
Yeah, I'll maybe just explain to our listeners what a SensorPod is and what we did there. So in the very beginning, when we started Kodiak, we said, well, how do we make sure this is maintainable? How do we make sure that a truck that goes across several different states and needs maintenance every now and then, or even has a sensor fail at some point, because of course that will happen, no technology is perfect, then how do we actually get that replaced? Because the number one thing we learned from our customers talking to them every day was like, well, these trucks need to be on the road to make money for me. And it goes the same for us. Like if our trucks are not on the road, then they don't make money. Now, it turns out this is the exact same thing in the defense space, right? If you're out in theater, you want to be able to replace your sensors quickly. You don't want to go out and have to calibrate it or needing a turntable or something like this. You need to be able to get those vehicles up and running and keep them up and running. And so because of that, we said, well, how do we position our sensors in all of our hardware? And we found it to be extremely modular, to put all of them on the mirrors. And so that's really what the SensorPods are. They are basically two mirrors. If you look at our semis, you would probably say like, well, they're pretty big mirrors. And the reason is because they have to include the human-facing glass still. That will go away over time, so they will shrink considerably. And the defense pods already don't have that anymore. So the defense pods are noticeably smaller. They're a slightly different form factor to integrate on various different vehicles. But in general, the concept is the exact same. You have all the sensors concentrated in essentially two positions, one a left mirror and a right mirror, and that makes it extremely modular, swappable. We can calibrate it in the factory and then just put it on. And the swap of such a sensor pod only takes 10 minutes.
If you think about this from two different scenarios. One, traditional trucking, let's say you're going Dallas, Houston, or Fort Worth, El Paso. On either end of that spectrum, could you have sensor pods in storage? If something happens, they could be replaced there?
Yes, absolutely. Yeah. You can even give these sensor pods to someone who drives to a truck should something happen and actually gets it there. You could even put it into the vehicle, right? Now, there you look at like how many times this has happened. It's probably not necessary to have it in every single vehicle, but you could if you wanted to. And then you have replacement parts there when needed.
And then in theater, you could have various, let's call strategic locations or forward bases, different types of bases. You can have the defense pods there as well, and they can be changed out in theaters with the same amount of time, 10 minutes.
Absolutely, yes. We have now integrated at this point into, I think, 5 different brands of vehicles across semis and like passenger vehicles and various other military vehicles. And we can actually swap the pods from one vehicle to the next. So it's not necessarily dependent on which OEM this vehicle comes from. And that, again, is a huge advantage to how many parts you have to have in storage, right?
I think about this, the maritime terms, if you're on a vessel and you have to Coast Guard rules you have to wear a life preserver, and they're on the vessels depending on the amount of individuals that are there on the vessel. This is more of a design question, but just thinking out loud from a logistical standpoint, could your design team, so obviously you have the Kodiak compute stack, but could your design team integrate SensorPod storage there, so no matter what happened, that vehicle always has a backup SensorPod on it, very similar to when you're on a vessel, you have a life preserver?
Yeah. I think that makes a ton of sense. And we actually took this concept further, right? It's not just the SensorPods. We essentially, all of our systems, they have three components. They have the sensing part, which is in the SensorPods and really modularized there. And then we have the compute, which is again very modularized. So it happens that our semis and our F-150s use the exact same compute stack. So we can swap between those, and we can swap them out between those vehicles. And that again makes it very modular. Now, and the third one, just to finish that thought, the third one is the actuation. The actuation depends a little on the vehicle, but again, it's very modular, and it's making sure that we have all the redundancy for that particular vehicle type and for the actuation that the vehicle has. So with these three components, we can go and upfit various different vehicles and make them safe, driverless vehicles. Now, eventually those will come from a factory line, but even there, if you have less components, less positions where you need to integrate, that is actually a huge advantage to going to manufacturing. And all of these modules can evolve independently over time because they have very clean interfaces to each other. So we see that as a major advantage, both for manufacturability, but also for keeping that maintainability in the field.
The same compute, SensorPods are swappable. Well, to me, I'm going to go to Denmark here. You have Lego blocks. I know you're from Austria, but we're going to go to Denmark because you have Lego blocks here. How did you design that system from a technical standpoint to be, let's call it the Kodiak Lego block system? Because to me, if I'm purchasing your product or I'm using your product or I'm evaluating your product and say, oh, I operate a mixed fleet and all this is swappable, to me, that's a game changer compared to your competitors.
Yeah, absolutely. That's how we see it as well, right? It needs less training for many technicians out in the field. The training is much more simplified, and it's way easier to actually swap it. And from a manufacturing point of view, it's great if you can actually hone in onto these systems and not have to develop a completely different one. So again, that's where I said before, it's additive, not actually distracting in all of these different use cases, because suddenly we have different vehicles. We do the same, for instance, shock and vibe tests on our compute, on road, and on defense. So suddenly our defense environment becomes a great shock and vibe test for the on-road cases, right? So that's how those really go together.
Yeah, the defense, let's go back 6 years to the founding of Kodiak. How is your approach to autonomous driving, to your developing the stack, changed?
I would say from the beginning, we looked into, well, what do we want to aim for? And we talked about not using HD maps. Now that in the beginning, for instance, we did this from the very beginning, but in the beginning it was a bet. No one had ever done it, but we just had learned from prior experiences from our team coming in from various different AV companies that it's a pain to have an HD map. It needs many people to actually maintain it. And like I already said, the temporal resolution is terrible, right? You have to update it all the time, and that requires a lot of work. So we said, well, how about we go and try to put as little into the map and to rely as little on it and to treat it more like a sensor. And so that is one of the concepts that we did from the beginning. But then over time, of course, we refined that. We can now use in the defense space, for instance, we can run in areas where we have zero map, no map at all. We've never been there. And that's, of course, a requirement for defense because you don't usually know where you're going in these cases to a detail of like an inch, a square inch, right, on the ground. So what we can do there, for instance, is we can use overhead images and say, well, here's your corridor, and that corridor can be pretty wide. And this is where I want you to go. Here's your bounds. Don't leave those bounds. And we send a vehicle there, and it searches for the best path within its bounds and arrives at its destination. So that is something we didn't have on day one, of course, and that we have developed. And maybe similarly on the AI side, we have always used AI from the very beginning, and we've always been very data driven, but we've gotten much more data. We're using lots of self-supervised technologies and methodologies. We use auto labeling. These are all things, and generative AI, as we discussed, these are all technologies that have popped up in the last years and have not been really the state of the art when we started Kodiak. But it's important to give yourself this framework where you can actually put these technologies to good use and put them in so that you're not static in your technology. And so I would say it has developed a lot, but the fundamentals are all the same and the principles are very much the same.
It's evolving. I think that's a very fair statement, because what you did was you built the technical foundation as technology evolved and advanced. What new technologies do you see on the horizon that could have a positive impact on the Kodiak driver that you could potentially integrate?
Yeah, I think especially on the sensing side, we do use LiDAR, we do use radar, we do use cameras. And we've never been particular about one of them being the main sensor. So all of the sensors really have equal weight in our system. We do a lot of early fusion where we take cameras and radar, camera and LiDAR. We take all of these methodologies together and we make sure that if one of those fails, then we never have a failure of the complete system. That's some of these neural pathways, they all try to not depend on everything, so that if there is a failure in there, that you can actually still drive the vehicle. And so with that, I think that while maybe 5 years ago, lasers have been extremely critical, nowadays they're actually still very important and useful, right? I don't think today we could build a driverless system that meets our safety standards and is deployable without the laser, but I think it's going there, right? We can actually do lots of ranging with only cameras and radar. And so that's maybe where the technology is going over the years, that we can even further reduce the sensor set. I think we already have the leanest sensor set in AV tracking, but we can further reduce that. And that goes back to what the cost of these systems will be overall and how you can further integrate it and mass produce it.
I fully agree with you. And there's economic data. If you add up all the publicly traded LiDAR companies, the market cap combined is under 2.25 billion, under that. I mean, that's after the route yesterday, but we're still probably just over 2 billion. There's not much there, and it comes down to cost. Do you see, is it going to be a depth sensing technology that breaks to a CMOS technology for camera? Will there be do you see a new camera technology evolving that could potentially accelerate the move away from LiDAR?
I think it's really in the AI that we see lots of improvements there, where you can actually estimate a lot of this from prior knowledge, from understanding of the world, of what the relative depth is to each other. So that makes it, even in the perception space, even more human-like. And we see that humans, of course, can only drive with our eyes. And we're not yet there, right? That's not yet something that I would sign my name under and say, yeah, I can go driverless and it's actually as safe as a human. But I think it's going there. Over the next couple of years, we will see a push towards this. And I don't think we need to invent new sensing technology for this. But today, we do need LiDARs, we do use radars, we do use cameras, and they're all incredibly important to meet that very high bar to actually launch in a driverless setting. And many people talk about, how do I build 10,000s of it? And that's very important. But you first need to launch your first truck. You need to launch your first 100 trucks. And there's a lot of operational complexity, a lot of, we call it the Kodiak driverless launch protocol, right? Like, how do you actually roll this out? How do you get it to the operations people on the ground to actually run it day in, day out, 24/7? And have a good experience, meet your SLA, right? It's really going back to an actual business. And that's what we're doing with Atlas. We're running an actual business. We ran this driverless run that we already did, was a commercial load where we delivered sand. And that's just incredibly exciting.
You are a business. I've said that to Don Burnett many times. Kodiak is truly business. And it's one of the main factors why Kodiak is number one on the leaderboard for autonomous trucking. And you're also number one on the leaderboard for defense, because yourself, Don, the entire executive leadership team and the board, had the privilege of speaking with them many times. We're a business, and that's really positive to see. So you're driverless now with Atlas in West Texas and the Permian Basin. What went into that launch from a technical standpoint? Was there the technical checklist that you alluded to that went into that? Was it rigorous safety testing? What went into allowing you to launch fully driverless with Atlas in West Texas?
Yeah, absolutely. We have a very rigorous test process for this, and we definitely don't take that lightly. Like I said, in the very beginning, safety is our number one priority there. And it's not worth doing things that are not safe, right? That's what our customers expect from us, but that's also what we ourselves expect from the technology. So what we do is, I already talked about the different pillars of the safety case, but you go and do a lot of testing on that. You do a lot of verification, validation on the track, on the road, lots of miles that we drove, but especially in simulation. And in simulation, you can go and look at things that you have never seen, that have never occurred. Because even if you look at 3 million miles of data that we have collected so far, that's not enough, right? There's still lots of things that can happen in the real world that you have never done. So that's where you go into doing really a top-down analysis. It's what is often referred to as a safety case. You go and look at how likely are certain things to happen? What's the severity of them if you don't perceive them or plan around them correctly? And then you go and check those off and you say like, well, is this actually a risk that is still there and that I need to mitigate more? And you go and put mitigations in place for those various different risks and you check against it. Now, this sounds like a one-off process. You do this once and then you go launch, but that's not how it is, right? You actually have to live monitor this. We call it a life safety case, where you take all the data that comes in and then refine it. And you say, well, are there any surprises in my data? Is there anything that I didn't model or that I didn't fully understand? And even there, you don't want to wait until, say, a collision happens. You want to see some of the early indicators of that. And you want to measure those and make sure those actually get flagged. And our triage teams, our simulations teams pick up on this, and that creates priority work items for us. So that's kind of the flywheel there, both in terms of machine learning. We have an active learning flywheel where we take that data and continuously refine it. That's incredibly important. That is actually what makes these systems work. But not just on the machine learning side, right? Like you want to know this about the hardware, about how good is your hardware? Do I see anything getting loose or not actually working together the right way? Do I see any bit faults on a CAN bus? And I think people often take this as like, well, I can do it all in simulation. But obviously, hardware is incredibly important, and we have a system that needs to work reliably and redundantly. And just one more example here, people often think of redundant braking as being super important. And of course it is. So we have triple redundant brakes. But if you go and say, well, my compute could also overheat because dust was collecting in the air intake, right? As an example. Well, that's not as obvious in simulation. That's not as obvious to come up with and say like, well, you have to actually fix this. But it's a very simple maintenance item in various different systems that we employ all across the world. So these are learnings that you have out in the field and that are actually incredibly necessary to launch this technology safely.
You see, this is fascinating because you hit the nail on the head. This is me personally speaking. I don't think a simulation-only approach works for a variety of reasons. I could go down a 3-hour conversation with you why. It's a tool, but it's not the only tool. When you're pressure testing it, you look at sand. So you're running through all these crazy elements. And in West Texas, it can get hot. You can cook an egg on the road. It gets so hot. Do you run these trucks manually through all these different scenarios and plan for what if, or say, wait a second, what if we blew dust in here? What would happen to plan from all this from its real world practicality? You're not operating in a clean lab at the end of the day. There's elements there. There's birds, there's winds, there's all sorts of stuff, and it hails. So do you run through all these different real world scenarios outside of simulation to learn and understand how the truck would adapt?
Yeah, that's absolutely right. Like temperature, there's great temperature chambers that you can put your hardware into, right, where you actually run through temperature cycles. So we have an incredible hardware team that goes and tests the Autonomy hardware. We also use trucks that are built for this, and trucks are really an incredible incredible vehicle, right? Like building these trucks over years and years and refining them, they're incredibly hardened, but they still break every now and then, right? They need maintenance. And so learning about what you actually need and what you need to do when, that makes makes your hardware really work extremely well. But before that, you go and test it to that. You go test it with temperature cycles, you do accelerated live testing, and you make sure that you can withstand those different conditions. And that can be from rainy conditions, from very cold, snowy conditions to super hot conditions. And that's what we run our vehicles through.
From the hardware perspective, especially from the compute, and you're running in, we'll keep going back to West Texas, where you're running a military. Do you have to build different types of cases? If you look at it in a military application, potentially a bad guy could shoot out the GPUs, could shoot out that. And then in West Texas, you have the heat issues. Are you looking at liquid cool potentially running in West Texas, while in the defense, perhaps there's some modified defense version of the case? How are you building your enclosures for the different environments that you're operating in?
Yeah, I would say at the moment they're very similar still. And they, it's more about the redundancy in there. If someone really shoots out your sensor pod, I don't know that the enclosure really helps you that much. And so that's where you actually want to say, like, well, if any particular part of the system fails, I want to be able to detect it and react to it. And reacting to it, for instance, in an on-road and in a highway case, it usually means to pull onto the shoulder. It means to pull over, make sure that you're clear of the regular driving surface, that you're not blocking anyone else. Now, there's cases where you might actually just have one lane and you actually stop there. Then you want to stop in lane. But again, you want to then be able to give a call to your 24/7 operations center, which we have, and notify someone who can then, depending on what the issue was, come pick up the vehicle. But ideally, you don't even wait for that because you will be blocking the highway, right? You actually have means to get this vehicle onto the side of the road through remote assistance. And that's really powerful in these environments as well. Now, we talked about the sensor pod being essentially, say, one of them is actually damaged, that in a regular on-road case, that might actually be a problem that you don't want to recover from, and you want someone to come service the vehicle. But in a defense use case, depending on what your mission is and what you're doing, you might actually want to continue. And that's really down to the commander in the field to say, hey, what is my mission? What do I actually need to do? And I think we had a lot of learning now working the last 2 years with the Army about this to say, how can we support our customer? And that's, again, one of the pillars of Kodiak from the beginning is we're going to optimize for what our customers need, be it on-road, where we work with various different large companies, large carriers, but also shippers across the US. And we work with them very, very closely to see what do they need. And the same goes in the defense space, and the same goes, of course, with Atlas, who are a very valued customer there in the Permian Basin.
You're optimizing for your customers' needs, which you mentioned this environments. What environments can Kodiak operate in today, and what environments do you see Kodiak operating in the future?
The environments, we call it operational design domain. They're very far stretched for us because we have such a versatile system. So from highways all the way into the field, as I said before. And there, of course, all of these need hardening in this case, and you go after what the actual use case is. We started with the technology in the Permian Basin now, where we have actually been able to take the driver out, show that we're safe enough to be driverless. And so that has been an incredible push to get that out. And it's actually it's a really big stepping stone for building trust with people as well, because it's hard for many people who are not as close to the technology to see from day one that, yes, you build a driverless safety case and you run it at 65 miles an hour on the highway with a big semi and an 80,000 pound vehicle. And building this up over time, showing that, look, our redundant actuation actually works and it is safe. It is the use cases with oncoming vehicles in the Permian and actually hauling sands, maybe at lower speeds first, but having still to react to all the other vehicles, to pedestrians, to vehicles that I had never seen before that exist in oil and gas fields. And they're weird looking vehicles, but still our truck needs to react to them properly and safely. All of this builds up trust. And I think that's incredibly important for our industry to build that trust, to show people that this works, because we can run mathematical models and do analysis and simulations all we want. It's really to gain the trust of the general public and the people who use it that is the critical piece in the end. And many people are not as mathematically inclined that they just trust a large probabilistic model.
Without trust, there is no autonomy. There's no warehouse autonomy. There's no autonomy in the QSR quick service restaurants. There's no in Class 8. Trust is that magic glue that holds it together. But it's happening, it's building, the public is being receptive. We're seeing really good polling data. The public believes in this technology because autonomy helps to fight inflation, and autonomy is good for the economy, and it's going to usher in what we call the autonomy economy. Kodiak today is operating on Class 8 trucks. You're also operating as a Ford F-150 through your DoD Department of Defense programs. Are there any limitations to the vehicles that the SensorPods could make fully autonomous today?
I don't think so. We always, for every vehicle, of course, we look at what's the field of view requirements, right? And we have to go and look if the vehicle is weirdly shaped and articulated. Of course, we optimize what the SensorPods see and what is necessary to see so that we can show safety at the end of the day. And that is the only constraint on it. But other than that, the sensors that we have there were incredibly flexible in terms of what exactly we use. It often doesn't come down to the exact specs of a sensor. It comes down to what the reliability of the sensor, the lifetime of a sensor is, right? You can combine various different sensors to achieve your goals. But if you make sure that is true, then we can put our SensorPods into various different use cases.
Different use cases equals, which I said earlier, a diversified business. Kodiak from day one was built to be a business, not to be a science project. Andy, how do you see the Kodiak business growing over the coming decades?
I think we're on an incredible growth path now, with industrial actually being an area where we can make the entire company profitable. That is just something that is very new in the AV space. And that's something we're incredibly excited about, and where we are now at the forefront of deploying this driverless technology. But of course, the sky is the limit, right? Like there's lots more that we can deploy in the defense space. We already got a $50 million contract to develop this technology, but that's only the beginning in defense. We can scale this much larger. And of course, again, we want to deploy this as a product. So we're working very closely with the Department of Defense of making that a reality. And then the biggest space, of course, here is on-road trucking, where there's lots and lots of trucks that we can actually deploy and help people by doing so. Because we all want our goods to be delivered and have them at home. And there's less and less people who actually want to do long-haul trucking. Short-haul logistics is something where the jobs are local. But if you do long-haul, you're on the road for very, very long times, very long durations. And many people don't want to do this anymore. So to summarize this, I think Kodiak is ready to automate any jobs that are dull, dirty, or dangerous. And that's really what we're focusing on. That's where we want to help people with. And I think there is an incredible amount of industries and technologies industries and areas out there where our technology can help a lot. And we're committed to making an actual product that helps people rather than just throwing a technology over the fence.
And I want to add this. I said this before. You're building a business. You're helping people, but you're also building a business that's going to reward your shareholders. Because if you look at the global economy for various different applications that Kodiak's involved with or not involved with, we have growing labor shortages. There's growing labor shortages in the fast food industry. There's growing labor shortages in over-the-road long-haul trucking. There's growing labor shortages in forklifts. And I read an interesting thing today in the Financial Times. There's a growing shortage of masseuses, people that give people massages. And so now that's getting automated. In New York now, there's an automatic, fully autonomous robot that gives you a massage. So there is growing labor concerns, and automation is going to fill that void. If you look at the Kodiak expansion into industrial, there's a lot of job shortages there. You're going to fill that void, and your customers can be able to build big, profitable businesses because technology that you're developing. When you put Kodiak in defense, You're going to allow the United States Army and military to conduct the missions that they have to conduct because you're keeping our men and women out of harm by creating really great technology. And over the road, you shore up the supply chain. We all saw what happened in COVID. In my opinion, if we had autonomous trucks at the port of LA San Pedro, we wouldn't have had the backup we had. And that's what we need. Your technology you're developing at Kodiak is good for the economy, the U.S. economy and the global economy. Andy, it's always wonderful to have you here, and this has been fascinating. As we look to wrap up for today, what would you like our listeners and viewers to take away with them?
Absolutely. Thanks so much, Grayson. This was a great conversation. And for me, you said it perfectly. We're building a real business. We're really moving this toward profitability, which has been something that has been missing in autonomous vehicle development and technology for a long time. So it's really about building a real business that adds safety, adds productivity, and makes sure that we can help people with it in all of these different areas. And I think we're on a great path to this. Kodiak is growing, so we're always happy to talk to new customers, to new team members, and get everyone in who can help us and who wants to help us on this journey. It's an extremely incredible and exciting time to now really have launched this year the first driverless semi-truck in a commercial application. And yeah, stay tuned. We're going to launch more driverless vehicles, different types this year. And yeah, it's going to be awesome.
Kodiak's going autonomous, and Kodiak's building a business. The future is bright. The future is autonomous. The future is Kodiak. Andy, thank you so much for coming on the road to autonomy today.
Thanks. It was a pleasure. Anytime.